Hi, this is section 9.4b. We want to do proof by mathematical induction. And so we'll get into that in a moment. But what we want to try to start with is a warm-up. And so we want to look at this problem right here. Why don't you read that, pause, and then I'll come back and then we'll summarize this. So drug companies have to do this all the time as far as testing their drugs. And so we look at limits, a lower limit of 50 and an upper limit of 200, then it's unsafe. So we want to make sure that we stay within those bounds to make this work. So what happens is that if I take this pill, and the first pill is 100 milligrams, what happens after 1 hour? Well, it says it dissipates by 20%. That means 80% is left. So I'm going to have 80 milligrams after that time. And then if I have 80% of that, then I'm going to have 64 milligrams in the next hour and continue this. So a trick on your calculator that you can use is if you do 100 times 0.8, you get 80. And then you can take the answer, ANS, and multiply it by 0.8. And if you do that, what we can come up with is the 64. And then if I just do that redundantly, it will keep on going. So it takes my previous answer and multiplies by that 0.8. So these would be the values that I plug into my table. So this is how the table looks. And so if I want to maintain my 50 milligrams, where would you say that you had to take another pill? Well, I'm going to guess that you're going to say either here at 3 hours or 4 hours. I believe that most of you would say at 4 hours because that's really close to the 50. Now that might be too close. It depends upon the drug company and what's happening. However, if we keep on taking this pill every 3 hours or 4 hours, we can see what happens by making a recursive relationship. And so we'll go to our calculator and try to set this up. So here are the two formulas that we might try. So this one right here would say that I take 0.8 multiplied by the previous term. How many times did I do 0.8? Well, if it's 3 hours, it's going to be applied 3 times. And then I'm going to add another pill after those 3 hours. So we're going to see what happens with that. And then if you do 4 hours and wait 4 hours, this would be the recurrence relationship with that. And then we start at a sub 0 being 100. So we're going to type this into our calculator. So on our calculator, we want to get a new screen. So we're going to go here, new document, and we're going to add graphs. And so if I look at this entry, I don't like this entry. So I'm going to go to menu, and I'm going to go to graph entry number 3. And under that, there's a sequence number 6. And I'm going to pick that sequence, and I end up with this right here. Now this u sub 1, once again, is just like your a sub n. They don't do subscripts here, so it's of the function n. So wherever we had a sub n, we're going to put u1 of n. So we're going to end up with u1, and if this is the second equation, you'd put u2. Depends which one you're in. And I'm going to go times the previous. So this is now is equal to the previous term. And I'm going to put in whatever we had there. We had 0.8 raised to the third. And we're going to add in another pill. After 3 hours, we're going to add in another pill. And we said our initial term is 100. Now, if you look at here, this means that my initial locker cell is going to be 1. I don't want that. I want it to be 0. So that's what I'm going to start off with at times 0. And what we can do now is we can go ahead and graph that. It should show up. Where? Well, it's got to be way up at 100. So I'm going to change my window to this here where I got -5 to 50 on my x's. I just made up some values. That's on my hours. And then also I'm going to go y -50 to 200. I'm going to max out at 200. If I go over that, I'll probably see that, and that's where I don't want to go. And I put -5 just because to make it look nice. Okay, so I'm going to go okay there. Now where is my function? Uh-oh, my max of 200 was not enough. If I take one every 3 hours, if you notice, I am going to go over that amount. By how much? Well, I don't know what that value is exactly. But what happens is that I could find that by doing what we call the fixed point. And we'll probably do that later, but you can take x and then solve for x out of this situation, and we'll find out what this horizontal asymptote is. If I want to graph regular again, then I go graph entry, and then I want to go back to function, and then I'd put in 200. And it looks like I did go over 200 if I'm taking a pill every 3 hours. Now, if you notice, how efficient is this drug after time? Well, it's going to be pretty efficient. It's going to be pretty consistent. And that's what they usually look for drugs, is a consistent amount in your blood at a certain time. Now let's try if we do the same equation, this one right here, except for we do it under 4. Now we have to make sure that we have at least 50 milligrams in our body over the time. Now if we look at that, well, we need the lower bound again. So graph entry, I want to do function again. What if I put in 50? So this would be my lower bound, and this would be my upper bound. Now it looks like if I take one every 4 hours, the consistent amount is within those limits. And so if I let's even try this. What if I try to the 5th power? Didn't change. I got to change this to the 5th power. And push enter. Well, I'm still in the limits. In fact, you could figure out where you'd be so that the drug amount is still okay in your body. What I did was I put a slider in here for the exponent, and so you could actually figure out which value you want. So like if the optimal amount is to have 70 milligrams into your bloodstream consistently, what you could do is just take this slider, and I want to just go like this. And so this would be take it every 6 hours. This would be take it every 7 hours, 8 hours, 9 hours. Oh, look at, I could take it once in a great while, and I would still be okay with this, okay? So you could figure out what would be the maximum or the premium amount to get into your body, depending upon which hour on the day that you want to take that. And so if we had 3 milligrams for this number 4, that's dangerous. Anything above that, then you would be safe. And you could figure out if you're, which one would be optimal for you. Now, if we do the next warm-up, this goes back to the pattern of road differences. Why don't you try this?